Next topic is close packed structures. So under this chapter, so we are going to learn how particles are arranged in the crystal. So first one is close packing in the one-dimensional structure. So in one-dimensional, the particles are arranged linearly. So here each atom is connected. Here each atom is connected with the two other atoms. So the coordination number for this atom is 2. So next one is close packaging in two dimensionals. So this one is the first layer. So this is the second layer. This is the third layer. So like that the atoms are arranged. So this type we are call it as the AAA type. So here each atom is connected with the 4 other atoms like in the square arrangement. So we call it as the square close packing. So this atom is connected with the four atoms. So the coordination number is 4. See this diagram now. So this is the A layer. So the B atom is present in between the A atoms. So again the third layer is similar to the first layer. So again the fourth layer is similar to the second layer. So this type of arrangement we are calling it as the AB arrangement. So here the atom is here, each atom is connected with the 6 other atoms. So we are calling it as hexagonal close packing. So the coordination number is 6 because this atom is connected with the 6 other atoms. So next one is the 3-dimensional arrangement. So in 3-dimensional arrangement, so the atoms are arranged in the cubic form. So this one is a cubic form. So we call it as the simple cubic arrangement. So next one is the tetrahedral voids. Here this is the first layer. So this is the second layer. The second layer is placed in between the first layer. So and the third layer is similar to the first layer. So on the fourth layer is similar to the second layer here. So here while forming while arranging the atoms like that, so we are seeing some gaps in between the atoms. So this only we are call it as the voids. So the upside triangle voids. So this one, so the upside triangle void we are calling it as the tetrahedral void. So the downside triangle void we are calling it as the octahedral void. So afterwards we are keeping that second layer above this one, means we are getting the structure like this. So afterwards we are connecting the center of the atom, means center of all the atom, means so we are getting the structure like that. So this only we are calling it as the tetrahedral voids. So next one is the octahedral voids. So this is the first layer. So afterwards we are keeping the second layer like this, means so we are getting the structure like this. So afterwards we are connecting the center of the atom, means so we are getting the octahedral structure. So this only we are calling it as the octahedral voids. So the number of voids depends on the number of close packed spheres. So the number of close packed spheres be n, the number of octahedral voids generated is equal to the n. So and the tetrahedral voids is equal to 2n. So and the formation of next one is the formation of the third layer. See this one, this diagram now. So this is the A layer. So the B layer is present in between the A layer. So again the third layer is similar to that of first layer. So this one we are calling it as the ABA arrangement. So this type of arrangement we are seeing in the hexagonal closed packed structure. So this is the first layer. This is the first layer, layer A. So we are connecting the atoms in the first layer, means we are getting the hexagonal shape. So we are connecting the atoms in the next second layer, means we are getting the triangle shape. So again, then the third layer we are connecting the atoms, means we are getting the hexagonal shape. So we are call it as A type. So next one is the hexagonal packing. So this is the A layer. So again B layer we are getting the triangle layer. So again the third layer we are getting the hexagonal shape. So again the fourth layer we are getting the triangle shape. So like that only the atoms are arranged in the hexagonal hexagonal crystals. So this type of arrangement we are seeing in metals like magnesium and zinc. So next one is the cubic closed pack structure. So that this is the first layer. The second layer is placed in between the first layer. Third layer is placed in between the second layer. So and the fourth one is similar to that of the first layer. So we are call it as ABCA arrangement. So we are connecting the atoms in the first layer, means so we are getting the hexagonal shape. So we are connecting the atoms in the second layer, means so we are getting the triangle shape like this. So we are connecting the atoms in the third layer, means so we are getting this type of triangle. So we are connecting the atoms in the fourth layer, means we are getting the hexagonal structure. So we are calling it as ABCA arrangement. So this type of arrangement we are seeing in the cubic closed structure. So in copper and silver, so we are seeing this type of arrangement. So first layer, hexagonal layer. So second one, this type of triangle arrangement. So in the third layer we are getting the this type of triangle arrangement. So again in the fourth layer we are getting the hexagonal structure. So we are seeing this type of arrangement in copper and the silver. So in the center one, in the center atom is in orange color here. So in the second layer, so this type of arrangement here, this triangle. These three are the extra atoms are attached with the triangle. So in the third layer, so these three atoms. So these three atoms are the extra atoms attached with this triangle.